Today we're going to be talking about similarity transformations. So what this is you have a dilation, I should say. It's a transformation that enlarges or reduces an original figure. A dilation produces a similar figure so that the dilation is called a similarity transformation. So if you look here, okay, in blue is your original. So this is my original. And if I enlarge something, my scale factor is going to be greater than 1. So I've enlarged this where triangle FGH is similar to triangle RST. So I have a similarity transformation. Those two triangles are similar, okay? And RST is larger than the original figure. If your scale factor is between 0 and 1, then you're reducing. So ABCD here is my original, and then I'm reducing to the smaller one. What this is a good application of is on a projector. So think about the projector in a classroom. My screen is being projected out of a projector onto a much larger screen, or even a movie theater, okay? You're projecting from your projector point some image that's in the lens to something that's bigger, a bigger, larger screen, okay? Okay, so first example, determine whether the dilation from figure A, so this is my original, to figure B, so that's what I'm going to, that's my new one, is an enlargement or a reduction. Then find the scale factor. So A, let me highlight A here for you guys. A is that one. Okay, so going from A to B, my side lengths got smaller. So that's a reduction. Okay, so going from A to B. So let's look at the length of one of my legs. So the length of one of my legs is 1, 2, 3, 4. 4, so the original over my new one, 2. Well, that doesn't make any sense because I told you guys the scale factor was going to be, if it's a reduction, it's less than 1. So my scale factor here is 1/2 because I'm going from 2 is my new one, 4 is my original. So it's new over original to get your scale factor. I apologize on that. I don't know why I'm confused on that. Okay. So I'm going from A to B. Notice how from A to B, our scale factor got bigger. So this is in enlargement. This side, so I have to go to my new one first, new one first, new one first. 3, 2, 1. I don't know why I wrote a 1. Why I wrote a 3 instead of a 1. So that is my enlargement. Okay, photocopy. A photocopy of a receipt is 1.5 inches wide and 4 inches long. Okay, so I'm 1.5 by 4. By what percent should the receipt be enlarged so that the image is 2 times the original? What will be the dimensions? Okay, so that my enlargement is 2 times the original. Okay. So my new one is twice as long. So my new dimensions are actually the easiest part to find. So I have 1.5. My new image is 3, or my new width is 3 by 8. So 3 inches by 8 inches. Now the hard part, I think, and I was trying to think of how I was going to explain this to you guys. By what percent should the receipt be enlarged? Okay, well, if I'm trying to double it, I enlarge it by 200%. So that's going to get me my much larger receipt. Okay, graph the function, graph the figure, and its dilated image, then verify that the dilation is a similarity transformation. Okay, here, so I am going to graph, we'll do blue being my original, -6, -3, that's M. N is 6, -3. And so that is N. And then I have O, which is -6, 6. Okay, and then we'll do the other one in red just so it's easier to see. D is -2. 1, 2. Oh, -1. To go in my Y direction. 1, 2, -1. -2, +2. And so that was D, F, G. Okay, so let's look at some sides here. Let's look at my image, the side DF. That is 1, 2, 3, 4. So I'm going to look at side DF, my original, my new one, compared to my original, MN. Okay, and let's figure out if this is a similarity transformation. So let's figure out what the scale factor is. DF, as I just said, was 4 units. MN is 6 and 6, so that is going to be 12 units. So that reduces to 1/3. So we know it's a reduction because my original, which is in blue, is larger than the image. So that's being reduced by a factor of 1/3. So it's making it smaller. Let's check OM. I lied. I don't want to check OM. I want to check GD to OM. Well, GD is the length of 1, 2, 3 over OM, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's also 1/3. So I have two sides that are similar. We have a right angle here and a right angle there. So yes, it is a similarity transformation. And we know those are similar by our side angle side similarity postulate. Okay, thank you for watching my video on similarity transformation.